let's take a look at tangents. This is a little bit different than the tangent that we talked about in the trig unit. This is a part of a circle, or specifically, it is a line in the plane of a circle that intersects the circle at exactly one point. Okay, at exactly one point. The point of tangency is the point where a tangent line intersects a circle, and there's some things that we know about that relationship, so let's take a look at those. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So what we're saying is if this line right here is a tangent, then the line that from the radius, the segment from that is the radius that meets at the point of tangency, that's always going to be 90 degrees. Okay, that's going to be perpendicular. All right, let's take a look at this. So, like I just said, if BC is a tangent, then AB is perpendicular to BC. And then we have a converse statement down here. If a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to the circle. So it just works in both directions. That's all that we're saying here. Okay? If you need to pause it here to get the rest of that slide, you go ahead. So let's look at some problems. On this one we have, for example, if CB is tangent to circle A, the radius is 20, so let's label stuff as it's told to us here. This is 20, and BC is 15, find X. So we have to apply information to other parts of the circle. We have this is 15 and this is 20. We also know that AD is 20 because the radius is the same for the whole circle. I also know that this is a right angle because of what we just learned. And so now I have a right triangle, and I'm missing some information on it, and I can use the Pythagorean theorem. So the setup here is 20 squared plus 15 squared equals, and then here's a little bit of a hard part for us, this is 20 plus x squared. This whole side right here is the hypotenuse. So that's 20 plus x, and that's in parentheses, squared. Alright? So let's move this up a little bit so we have some room to do some work, because we're going to need to do some math here. Let's take a look. 20 squared is 400. Okay. 15 squared is 225. And this missing side right here, sometimes it's useful just to think of this as the hypotenuse squared. So I'm going to not use 20 plus x for a second. I'm going to show you something. If I just thought of this as the hypotenuse squared, okay, what I'm able to do then, so what we can do here is we'll add 400 and 225, and that gives us 625 equals h squared. And then the square root of both sides here is 25. So h equals 25. Then I want you to go back to that first part. Remember when we substituted this out and put this in, what we're saying now is h squared equals 20 plus x squared. On this problem, if the h is 25, then this equals that. We're saying that we found this missing side, it's 25. We know this part to be 20, so the missing part, the missing side, has to be 5. Alright, let's take a look at this one. If CB is tangent to circle A, and DC is 32, so this part right here, and BC is 40, so this part right here, find X. Well, again, we know it's a right angle. We know I'm going to use Pythagorean theorem again. If AB is X, then AD is also X. So let's go ahead and use our Pythagorean theorem here and get x squared plus 40 squared equals x plus 32 squared. Now this unit is sometimes hard for students because we forget things that we know, like how to multiply a binomial. We're going to use FOIL here. So we have x squared. 40 squared is 1600. And then this is, x plus 32 squared is the same thing as x plus 32 times x plus 32. So that is FOIL, multiplying binomials. Have first term times first term is x squared. We have 32x plus 32x, that's the outer times the inner. And then the last term, I don't know 32 squared off the top of my head, so let's see. 1024. Alright. Then we're just going to solve for x. First thing, I notice that I have an x squared on both sides, so if I subtract x squared from both sides, I'm left with 1600 equals 64x plus 1024. That is not a 4. Make it better. There we go. Then if I subtract 1024 from both sides, I have 576 equals 64x. And then 576 divided by 64, and x equals 9. So x equals 9. Okay? This part up here is where students sometimes struggle. This is the old algebra stuff you got to remember. Let's take a look at this. If two segments from the same exterior point are tangent to a circle, then they are congruent. So here's what that means for this example. If CB, and we'll mark it, if CB and AC are tangent to circle P, then CB is congruent to AC. So we're saying if these two are points of tangency, then these two segments have to be congruent. That's all we're saying. And there's some pretty simple and then some pretty complicated problems that we can solve based upon that information. So let's take a look. CB and AC are tangent. And then we say that BC is 3x minus 7. AC is 62. This would be one of the easy ones because we're telling you that those two are congruent. If A and B are points of tangency, then 3x minus 7 equals 62. And 3x equals 69. And x equals 23. Easy enough. Let's take a look at the next page. Determine whether each segment is tangent to the given circle. So to determine whether or not it's tangent, we really want to know, is this right here, is that a right angle? We just test the Pythagorean theorem here over and over again. Right here we're going to test 16 squared plus 30 squared, and we're going to see if that equals 34 squared. So let's go ahead and test that out. 16 squared is 256. 30 squared is 900. So that's 1156. And 34 squared is 1156. So the answer here is yes. Okay. Here we have 3, 4, and 5. We should know at this point, we should recognize that right away. 3, 4, 5. 3, 4, 5 is a right triangle. 9 plus 16 is 25, and 5 squared is 25. Alright, let's take a look down here at the bottom ones. Here we're solving for x. We're looking for that distance. If this is 12, and we know this is 12, so let's, it says all segments that appear to be tangent are tangent, so that's a right angle. So then we have 12 squared plus x squared equals 12 plus 8, which is 20 squared. So 144 plus x squared equals 400. X squared equals 256. X equals 16. Let's take a look at the one on the right. Here we're looking for this whole distance right here. So 7 squared plus 12 squared equals x squared. Alright, this is 49 plus 144 equals x squared. This is 193 equals x squared. And let's go ahead and take the square root of 193. That's 13.9. And that's it for that page. Let's take a look at what's next. More practice with tangents. So this doesn't look like what we just did, but it is the same exact thing. We're going to test what we know about tangents based on the fact that if these are all tangents, assume that they're tangents, then this distance from K to L is the same as this distance from K to J. Okay? So the easiest way to do these problems is just to work your way around the shape. And here's what I mean by that. If and you just start with numbers that you know. If this is 4 right here, then this also has to be 4. Okay? If this is 2 right here, this also has to be 2. This whole thing is 5. So if we've already used 2, all that's left right here is 3. And if that is 3, then x is 3. Okay, you're just working your way around the shape. You label what you can figure out, and the rest, you just label, you're going to add and subtract to label the parts. Here we have this is 8, so this is 8. This is 4, so that has to be 4. This is 6, so that has to be 6. And we're missing this side right here. This is x, so x is 6 plus 4, so that's 10. That's it for tangents, guys. Pretty simple video. Go ahead and try 8F. We'll work on that in class, or you can work on that at home, your decision. But pretty simple stuff. I would go ahead and get started on it, so I had some questions when I came to class. Thanks to those of you who asked me for more notes over the break, over this like 4th winter break we've had. You are a leader amongst men and women. Leaders amongst men and women, because there was multiple people that wanted these notes. Of course, one of them was me, and the other one was Miss Monroe. But whatever. Here's the notes. Have a blast.